Okay, so we have this guy in a car here, and he launched himself off of a ramp at an initial speed of 25 meters per second. The ramp had an angle of 42 degrees. He was originally on an 80-meter tall cliff, and he's trying to hit this crash pad over here that's on ground level, which we're calling 0. What is the distance, or how far will this car travel? So I have all the variables in the problem listed over here, and the equations that you're going to need to know are going to be these equations right here. This equation deals with everything in the vertical direction, and that's why we have gravity as our acceleration, since gravity pulls objects downward. Now over here, we have everything in the horizontal direction, and since there's no acceleration horizontally when it comes to projectile motion, this equation is pretty simple. We have a v0 y here and a v0 x here, so we're going to need to calculate for the x and y components of our initial velocity, and the way we can do that is using the sine and the cosine. So here, your initial velocity times the sine of theta will give you v0 in the y direction, and your initial velocity times the cosine of theta will give you v0 in the x direction. So what I can do is take this and plug it in right there, and then take this and plug it in right there. This will update my equations to be a little bit more accurate. So now I have this equation and I have this equation, so I should probably use the vertical equation since I am using these variables right here. But notice that we haven't calculated our change in y. So your change in y is going to be your final position, which is 0, minus your initial position, which is 80. So 0 minus 80, that's negative 80. So this right here is going to be your delta y, which you can plug in for right there. So right here, notice that I've plugged in negative 80 for delta y. I plugged in 25 for our initial velocity, that was what we had. I plugged in 42 for our initial angle, that's also what we had. And we know that g is 9.8 since that's the gravitational acceleration on Earth. Now using basic algebra, you can solve this equation to get t on one side. And it's going to end up looking like this if you do the math properly. Also, if you multiply both sides by -1. You can see my steps above. And then what you can use is the quadratic formula to solve this equation. And I would advise doing this on your calculator. And this will give you these two times listed down here. Notice that I boxed this one though. The reason why is because having a negative time doesn't really make sense. So we're going to go with 6.08 seconds. So now that you have 6.08, we can go ahead and cross off this equation since we've already used it. And so we'll use our delta x equation right here. So delta x equals v0 times the cosine of theta t. Well, v0 is 25. We had that in our problem, so we have 25. This is multiplied by the cosine of, and then theta is 42, so 42 multiplied by 6.08 seconds. And we can just go ahead and multiply everything across right here. If you type that exact number exactly as you see it into your calculator, 113 meters approximately is how far away the car is going to land.